Hello everyone. In this lecture we are going to see how to find the epsilon closure of a NFA. So the epsilon closure that we use is consists of the states that are reachable from a series of 0 or more transitions. So if we start with a state say 1, then it will be the epsilon closure would be the set of all states that can be reachable from the state 1 following a series of 0 or more transitions. So let us see this with the help of an example. So here I have an NFA. This is the NFA that we have. So here I have 4 states. One is the start state. This is the start state. And this is the final state. And we have one input symbol which is A, and the rest are all epsilon transitions. So when we want to compute the epsilon closure of a set, say 1, 2, 3 or 4, we have to find out the set of all states that are reachable from a particular state following a series of 1 or 0 or more epsilon transitions. So epsilon transition, by epsilon transition we mean any transition from one state to another state that is labeled with a epsilon, like for example this. So let us create the table for computing the epsilon transitions of the various states. So let us first create the epsilon closure, of the start state 1. Okay, so we have to find the set of all states which are reachable from 1 by following some epsilon transitions. That is 0, 0 or more epsilon transitions we have to follow. So if it is 0 epsilon transition from 1, then I will always reach 1. So in the closure, always the state from which we start, that is always included. So here we are trying to find the epsilon closure of state 1. So 1 will always be included in the set. Then following epsilon transition, which are the state we can reach from 1? We can reach 2 from 1. So we can see we can follow this epsilon transition and reach 2. So the set 2 will be included in the epsilon transition. Epsilon closure of set 1. Now, can we go to any other state following epsilon transitions from 1? No. There is no other direct transition from state to state 1 on epsilon. So, our epsilon closure of state 1 is this set 1 and 2. Similarly, we can try to find for the others epsilon closure of set 2. So by default 2 will be included. Then we will see that from 2, is there any arrow pointing to any other state which is labeled with an epsilon. Now from 2 we don't have any other transition which is labeled with an epsilon. So our epsilon closure of set 2 is 2 itself. Then for set 3, for the state 3 we have again 3, so 3 itself. Then from 3, where can we reach using epsilon transition? So as we can see from the diagram, from 3 on epsilon we can go to 2, from 3 on epsilon we can go to 4. So the states 2 and 4 are reachable from 3 on following a epsilon transition. So the epsilon closure of 3 would be 3, 2 and 4. And finally we have the state that is the last state, that is 4. So epsilon closure of state 4 will include 4 itself. Anything else? Yes, following 4, from 4 on epsilon I can go to 1. So 4 and 1. So these are my epsilon closures for these sets, for these different states 1, 2, 3 and 4. So we can write it properly in the form of a table. So I have the states here and I have the epsilon closure here. So state 0, state 1, state 2, state 3. Oh, this is it's state 1, 2, 3 and 4. 0 is not there. So we saw that for 1 it was 1 and 2. 1 and 2. For 2 it was 2 itself. For 3 it was 2, 3 and 4. 2, 3 and 4. And for 4 it was 1 and 4. So these are the epsilon closures of the states. Now in the same way we can also have epsilon closure for a set. So epsilon closure for say A. Now what is A? A is a set of states. Set of states. So let's assume that, say, let A be the set of states 1 and 3. A is 1 and 3. Then what would be the epsilon closure of the set A? It would be the union of the epsilon closure of closure of 1 and epsilon closure of 3. So epsilon closure of 1 and epsilon closure of 3. So epsilon closure of 1 is 1 and 2. Epsilon closure of 3 is 2, 3, 4. So epsilon closure of A would be the union of these two sets. So 1, 2, 3 and 4. So in this manner we can find the epsilon closure of a set or epsilon closure of a single state.